Hello everyone, thank you for joining me today. My name is Haiqi Zhang, and I'm here to present our study titled Granular Analysis of Social Media Users' Truthfulness Stances Toward Climate Change Factual Claims. This research is a collaboration with Zhenyuan Zhu, Zeyue Zhang, Jacob Daniel DeVazier, and our supervisor Dr. Chenkai Li from the University of Texas at Arlington. Climate change is a critical issue affecting our environment, economy, and society. With the growing public awareness and engagement on social media, it's crucial to understand the discourse on climate change. This paper presents a framework aimed at understanding social media users' perceptions of various climate change topics and uncovering the insights behind these perceptions. In our framework, we first collect factual claims from fact-checking websites using climate change-related keywords. Next, we gather corresponding tweets using tokens extracted from previous collected claims. We then leverage LM with a human in the loop to automatically construct a taxonomy. Finally, we fine-tune a model to assess the truthfulness stances of tweets toward their corresponding factual claims within the taxonomy. We collected factual claims from 5 fact-checking websites: PolitiFact, Snopes, FullFact, MetaFact, and AP News. Using keywords from the Environmental Protection Agency, we identified relevant claims and their verdicts. In total, we collected 1,409 unique climate change-related factual claims. Next, we collected tweets discussing these claims. By extracting and tokenizing nouns, verbs, and adjectives from the claims, we were able to gather 13,050 tweets related to 729 claims. This allowed us to pair each claim with the relevant social media discussions. After we gathered the data, we built a taxonomy for the factual claims using LM with a human in the loop. In the prompt, we instructed LM to provide broad, medium, and detailed topics for each factual claims based on the learning examples we annotated. We then identify popular topics and select the most accurate claim topic sets as new learning examples from each popular topic. We update the model's prompt with new examples iteratively until the results are satisfactory. Finally, we consolidate the generated topics to construct a taxonomy. For truthfulness stance detection, we fine-tuned the Zephyr model using 1,871 annotated claim tweet pairs. The model classifies each tweet's stance as positive, negative, or neutral no stance towards the factual claim. Here is an example. A tweet discussing air pollution linked to dementia showed a positive stance towards the claim. The taxonomy results included 9 broad topics, 33 medium topics, and 13 detailed topics, with an accuracy of 83 for broad topics and 62.5 for medium topics according to human evaluation. For stance detection, the model showed strong performance with precision, recall, and macro F1 scores, all averaging above 0.8. From Table 2, we can see that people tend to believe a claim is true. Here is the stance distribution towards truth and misinformation across broad topics within the taxonomy. We found that the public struggles to distinguish between true and false claims, especially in topics like politics, economy, and environment. We also noticed there's a higher belief in claims related to health. In conclusion, our framework provides an effective way to analyze public judgments on climate change topics. We observed that the public tends to believe claims regardless of their accuracy, and people's judgments vary across different topics. This underscores the need for improved critical thinking and robust fact-checking interventions to enhance public discernment and the accuracy of information on social media. This work is partially supported by the NSF Award. We also acknowledge TEC for providing HPC resources. That's all. Thank you.